Hello, this is Lakshmanan Mayappan, and this is the project recording demo for CS441 MapReduce program. So here is the AWS, and this is the MapReduce cluster running with one master and two cores. So, so I have transferred the files to the cluster, the master node using SFTP, and here I have connected it using the putty SSL. So when if you see here, so we have the files, the jars transferred over to the EC2 cluster, the master node, and I have created the HDFS directory. So log process slash input is the input directory where we will be storing all these log files that are need to be processed by our MapReduce programs. So right now there is no data in the log process slash input directory, the HDFS directory. So right now that is put and stop log. Yeah. So right now we have transferred the files from the local machine to the HDFS directory, and right now we can see that we have 4 log files over here. Uh, so next we have to perform the first MapReduce task. So the first MapReduce task is finding the log level frequency. So that is like counting the number of errors, the debug, warning, and info, the count of number of occurrences across all the input files. So to do that, so we have the root jar log process log processing MapReduce, yeah. And first we have first argument is the input directory, so that is log process slash input, and the second is log process. So let's have like, since we are doing the log level frequency, so we'll get log level frequency or just log frequency for simplicity. And so the project is designed in such a way that you can specify which MapReduce task that we want to run over here. We can specify the pattern key, the job key. So the job key is like we have 4 tasks, and which task that we want to perform, we can specify that particular task in the argument so that the MapReduce program will perform that particular task. So yes, log frequency, and okay. So I have that particular directory already, the output directory. I delete that for now, and I'll execute this again. So yes, so here we can see the log message saying that we are doing the log frequency calculator, and the MapReduce task is starting to run. Okay, the map job is done. Yes. So let's see the output of this particular job. So cat okay, we have the total output over here, and that is fine. So we have debug info error 1. This is fine. This looks fine. So this is the output for the first MapReduce task, and let's try executing the second one with the most error. And for the second, third, and the fourth pattern over here, the most error in the time interval, the longest substring that matches a regex, and log level distribution and predefined time intervals. All these three supports regex pattern injection. So we can specify what kind of pattern that we need to search in these log strings, and these are all some of the supported patterns. So this particular project suppose 5 pattern, and you have the flexibility of choosing whichever pattern you want just by specifying this key over here. So this is the argument over here. We can specify the pattern key just like we did the job key over here. Uh, so let's do this example. So we go for Hadoop jar log processing. Yeah. And next we specify the input path. That is the first argument. Log process slash input is still the input path, and we go for logs process slash. So this time we're going to complete the most error for pattern 1. So we create most error pattern 1, and we specify the job key, that is most error, and we go for the pattern 1. So pattern 1 is just like while character and just matches everything. So right now we are essentially finding, we are not searching for any pattern. That's like a summary of this. We take in any pattern that we choose. So here we can see this is the pattern that has been chosen. So this most error task has two mappers and reducers. First mapper and reducer extracts the necessary information that we want, and the second mapper and reducer will sort them on descending order so that we'll be able to see the time interval with the most number of errors on the top. So the time interval can be configured in the configuration. So right now the settings is for 5 minutes. So the log messages is broken down into 5-minute time intervals, and the result of this particular job is to find out like which time interval has the most number of errors, which 5-minute time interval has the most number of errors. So we'll try printing this. Is Hadoop fs cat log process. So this is most error -1, and we print the errors over here. So yes, we now see that the time interval block, this is the starting of the time interval block. So on 17th of October, on the time block that starts in 21:45 to 21:50 has the most number of time errors. It has around 144 time of error messages in that particular 5-minute window. So this is the output of this particular pattern. Right now we just take the error messages which without any searching for any particular string. So let's now try by searching for a particular pattern. So let's now search for this pattern. If it exists, so this pattern 5. So we go for pattern 5 and we change the output directory to pattern 5. Now the sorting map reduce job is starting to run. So now let's check the output. Yeah, so only this particular time interval block has 5 error messages. So all other error messages that we previously got for searching for generic string like the wildcard, we accept what error message it was. So all those strings does not match with this regular expression pattern. So there are just 5 error messages that matches this pattern in this time block. So that is the result of this particular map reduce job. So next let us try searching for the longest regular expressions in the log strings. We can choose any log strings, but we search for a particular regular expressions. We search for the longest substring that matches this regular expression and find out the length of that particular substring. So we run some Hadoop char log processing. Okay, and now we specify the input path again, log process slash input and log process slash, now we are trying to do the longest regex, and we give the job key. And right now let's do this pattern. So this pattern searches for any substring that starts with an open parenthesis and ends with a closed parenthesis. So we'll search this particular pattern. Let's execute this. So the output is stored in logest regex. There is a typo over here. So okay, so this in the debug there is a pattern which has log strings, log message with that contains an open parenthesis and an ending parenthesis, and the length of that substring is 48, and for info it is 73, and for warning it is 72, and for error it is 34. So we just take the longest substring in that particular category that matches this particular pattern, and we print out the longest length of that pattern. And the remaining one is the log frequency distribution. So the log frequency distribution is essentially finding log frequency distribution, and we have to specify the job key, and this time we'll take up pattern 3. Pattern 3 is essentially any characters without any space or tabs or new line characters. So we'll be searching for the longest continuous string without any spaces or tabs. Okay, so log frequency and test. Let's try and print this. So this might look similar, but when we see the timestamp over here, it is on different dates. So on the different dates, we have the same time block, and there's number of debug instances of 7. But we can see like there are differences for different files basically. So this is the output for this. So all these values are, as you can see, it's comma separated. Now to take this value, so this resides in the HDFS directory. So HDFS, DFS, ls, and let's print what are all the folders that we have inside the log process directory that we have created. So these are all the folders that we have. So the intermediate, so the most error 1 intermediate and most error 5 intermediate are the output of the first mapper. So most error job has 2 mappers and reducers. So the intermediate is the output of the first mapper and reduces, and the most error -1 and the most error -5 is the final output. Right now we have to take this output and save it in a local file so that we can transfer it, so we can analyze it in our end. So the same way like we did for this, we do the cat, but right now we specify let's say output / log free test.csv. So we have an output directory over here, and we are storing the output files over here. So next we are done with the then So we get log frequency distribution, longest regular expression, and next is log frequency, task 1. So we still have to get 2 more outputs, most error 1, and next is most error 5. Right now we have we have all the output files saved to our local output directory. Now let's list this so we can see that all those output files have been saved over here. Just to make sure, we'll print one of the outputs. Okay, so we have the output in a proper format. Right now we have this SFTP. So in this SFTP, we'll try and pull the data from here. So we specify get, and we give this tag for the repository, and we specify the output. Oh, okay, so we are there in this log processing. So we give get, and we give repository, and we give log processing / output. It should be fine. Output. Okay, so right now we have this data. So let me open this particular directory. Okay, so right now we can see these 4 output files. Oh, we have the output files over here. These are all the output files that we have we got from the SFTP file. So we can open these files, and we have the results in the Excel format over here. So you can see the timestamp, the name of the log level, and the count for that. So don't say. So this is the demo for the log file generator and the log processing. So the log processing can be customized. So we can search for multiple patterns. So this is not restricted only with this pattern. So in order to search for multiple patterns, so we have to go to the source folder. Minor changes are need to be made. So we go to the our resources folder, and we just specify our interested pattern over here. So let's say like we are searching for a pattern that searches for null pointer exception. We can specify this particular pattern over there, and we can run this particular, we can compile this jar and run this on the map reduce program by specifying the map by pattern 6, and it will still run. So this is flexible, and it can be expanded, and the time buckets, the length of the time buckets can be customized over here. And this not only works for this particular log file, and so the regular expression that maps the strings of log, that maps the log strings in this particular log files can be changed or modified so that it fits and it works for any kind of log files. So this is the demo for the log processing MapReduce. Thank you.